the guys here are probably going to look at this and say, waterfall, old stuff. No, hold that thought. So let me talk about some of the characteristics here. First of all, the constraints are completely different for hardware. It's not like hardware guys plan to be bureaucratic. And when I hear Agile discussions about waterfall, it sounds like what they used to do in the 50s in Defense Department kind of stuff. This is not how hardware is developed these days. So first of all, things are very cross-domain oriented. There are obviously hardware developers. There are also operations people, driver people, firmware, RTL. There's just a whole lot of different kinds of skills, and they all operate differently. And so program management has to figure out how to work with each one of those and have them work together. And they all have dependencies on each other, by the way. Then material lead time is a significant factor. I didn't go through the drawing here, but let me do that for just a second. This is a chassis that's being developed. Here's the main path of development. There's a series of builds. Think incremental development. Okay? The design work is pretty much all done up front. I'm showing where they're doing the Verilog or building the database. There's going to have been a whole bunch of research done over here that I didn't put on here. But the design work is pretty much done over here. Over here, we're doing all this other stuff I'm about to talk about. The hardware programs are not all about design. Each one of these builds, there's material to be purchased, there's building to be done that's probably done in China by a CM or a TPM, and then the equipment is brought up and tested in various guises back here, or possibly also with the CM. Look at the material. It's not uncommon, in fact it is common, that you would have material like big silicon or even connectors that are 16 weeks lead time. So one of the things about hardware that people think the waterfall is it has to be planned in advance, and then you work back to take as much stuff off the critical path as you can, because we don't like long schedules in hardware. So David, you're talking about how lean can these things be. A lot of things that I'm going to talk about right here are about making things be short and quick. And they take longer just because of the physics, but there's a lot of effort taken to move around dependencies and get things off the critical path. So anyway, that's one of them. One of the other things here is that the deliverables are hard. When we put out hardware, it's difficult to impossible to update. A lot of hardware now is configurable or controllable by firmware. There may be RTL if there's FPGA. So there's some things that can be updated. Early in the program, you probably don't have all the infrastructure to make that all nice and automatic. It probably takes a tech going out and doing each one, so that can be a little disruptive. Later in the program, it's just like software. So the point is you can do that kind of updates, but you're never lucky enough if you have to do blue wires or what we call blue wires, that errors happen on slow paths. The problems we have are always on fast paths where signal integrity is an issue. And I, in the last 10 years, have never been able to update a board with blue wires once it's deployed. Okay, we always have to replace the boards with a new build. In the field, if we have issues, we eat the boxes. That's the nature of it these days. Most of the hardware function these days is contained in big silicon and controlled by firmware. And the design is about putting those things together in very intelligent ways and moving it through the rest of the system. So anyway, it takes time to do any updates because even if they're soft, they have to be done by technicians usually, and it costs money to replace the hardware. There's a lot of parallelism. Notice that there are a couple of places here where we're working on 3 builds simultaneously. And again, that's all about collapsing the schedule. Usually we know what the schedule is before we start because there was a business plan put together somewhere high up in the organization by senior staff about when you need this. There's an obsolescence issue, there's a new technology issue. Dell, for example, when Intel comes up with a tick or a top, they need to get that out in the server, out in the market in less than a year. That's no small task. It's not just the design, it's moving it all through all of the supply chain and logistics and all, and calls and all that stuff. So there are a lot of things that drive the schedule. So parallelism is one of the things that's used for that. Also, I said the design work is all being done up here, most of it. What's happening over here, two things. We're doing quals on the hardware to validate that it works well in all the conditions we expect to see. Some of the functional corners and environmental corners and things like that, regulatory stuff and all that. But the other thing we're doing through here is we're bringing up manufacturing. And bringing up manufacturing, you don't just hand it over to them. There's labs, there's assembly, there's also test. Test is a huge deal for this, developing test automation, especially as you get into high volume development. At Cisco, I probably spent more time on the floor with the manufacturing test guys than with the hardware guys. I spend a lot of time with developers, by the way. My background is as a developer. I'm doing program management because I love to do that. But I'm pretty deep into the development work there. I spend a lot of time with the customers. So we're bringing up manufacturing. Manufacturing is the assembly and test and all that stuff. It's also the supply chain. What we're getting, where we're getting it from, what are the specs, all that stuff. Okay, test maturity sequence, there's a test maturity stuff going on. When we do this here, this stuff is going to be hand-built by engineering. The next generation, they're going to do what they call 5DX or something like that, where it's photographic stuff that's looking for anomalies in the physical build. As we move on, we're going to get into things like automation of the diagnostics test. And being able to update firmware and stuff like that. That's all part of that. Later on, we'll move into ICT, and later on into things like installing licenses and things like that. You don't have all of that stuff up front, so that all gets developed during the course of the logistics going on over here. We have to build stuff for each one of those things, usually in special configurations. That's why a lot of what I'm concerned with when I'm working on hardware is the logistics of what do we need, when do we need it, what's being used for, and all that. Okay, so here's the difference between hardware and software. Hardware expenses are spiky. Every time we do one of these builds, we're purchasing hardware for it, components for it, we're doing the build, we get billed by the CM. We may have to buy some of the equipment frame to assign it to the CMs, but there's about every quarter and a half or so, there's a purchasing spike. Software, you have this many people, and you think that people are pretty much the same quarter to quarter to quarter. And we might work on this project or that project, and the expense is the same. That's not true for hardware. And the hardware part of the program has to define the budget and commit to a budget. If you have 3 projects in the organization, they can't all spike at the same time. In fact, when they do, there's usually fights about where we're going to spend the money. At Cisco, when I worked on the telepresence endpoint there, of the 5 quarters we were doing active development, 3 of them, our budget was cut to people only. And we did all of our bills in 2 quarters to the left. We did all kinds of fancy stuff. Anyway, the point is, the management of money is a big deal for building hardware. Also, I said we like short schedules. In the case of hardware, revenue is tied to FCS. You're really not getting a whole lot. You're spending money up until FCS, and then it turns green, hopefully, when you get to FCS. Where my experience with software has been, it's mostly a licensing model. And if we move the FCS of a new function out, we're still collecting the same license fee for the old stuff. So, full cost.
First customer show.
First customer show.
Yes, gosh, you've touched so many interdependencies that my mind is just revolving around itself. What do you mean by having, tracking shipments that can be stuck at custom and incorporating that into hardware, software, and talking about finance and expense to our finance people, and talking to our VP who is, you know, how lean can you make your program ahead?
So I'm not sure if I'm going to touch exactly on what you're saying, but I'm going to tell you a couple of things.
Let me just say what I mean. There are a lot of interdependencies that is going to lag the next dependencies.
No, David, they're not. This is all planned so that it doesn't do that. There is a huge amount of work that people like me do to make those interdependencies not cause delays. I spend 7 days a week on that stuff.
So for example, you mentioned custom. I used to work at Cisco. I know exactly what he's talking about, and because I used to do the same thing. We actually worked in the same business unit on similar products. Customs. So we look at historical data, especially for within the last 9 months of what's going on in different countries. Because not only does the country compliance change, and we have to be on top of it, and we have, like at Cisco, we have representatives who sit on these boards in the countries. This is changing and we need to stay ahead. And so we take that data, and so for example, in a certain country, it can be 3 weeks to get through. And so we build that into the schedule. And then beforehand, what we'll do is, after a while it's an ecosystem, you think that way. So in 6 weeks prior, you start pinging the folks for the customs, have all the paperwork done. Then we work with our suppliers, have that beforehand. Did you get into any trouble? Is there something new that came out of this province in China? Because you can get stuck. So we do that.
Thank you.
Yeah,
Thank you.
I know the critical path of every piece of the program at every moment. Like I said, I'm very tight with the developers and the ops guys. I know what's the critical path. I know what's the next thing on the critical path. If something moves, I know probably 4 levels back. And I'm working with the guys on making sure that something that just used to be critical path doesn't become critical path because of inattention.
Thank you.
Let me give you one other thing though about Lean. Cisco's business model, they're not the only ones who do this, but I can say what it is. They basically order finished product from their CM. And what that means is that they don't put money in. They put money into development. But when it comes to production, the funding for all of the inventory and the assembly and all of that stuff for the product that Cisco is going to ship is funded by the CM. Then it gets shipped. The CM bills Cisco, and the terms are probably net 30 or net 60 or something like that. Cisco collects the revenue because they only ship stuff when they actually are going to sell it. And then they take the revenue they get from the customers, they give it to the CM. They keep the profit. So in terms of Lean, all of the money is pushed out to the suppliers. So that's another form of Lean.
Thank you.
I appreciate that point you make about not wanting to have several of your hardware projects spike all at the same time. Can you offer any guidance, thoughts, experiences, wisdom, whatever, around the issue of, okay, you go ahead and plan as best you can to avoid the spikes of 2 other projects, and then one of them blows out their schedule, and then they're out of sync, so then you're going to start lining up with somebody else's spike. How would you cope with that?
So first of all, there's a management prioritization problem. You don't always win that. So my best experience with that, we were using a CM. We did things like we would have our CM bill us for material. First of all, we pushed very hard to get all bills done. I worked through a number of holiday seasons to have bills fired up, before Lunar New Year and after Christmas holiday and stuff like that, so we would get there. Then when they cut the funding, then the following quarter when it was complicated. We basically got the CM to bill us for material on hand, and the following quarter they just billed us for what was it called, variance charge, so that we didn't wait and save, we didn't save all of the payment until when we were actually going to get the equipment. So we avoided a big spike that way by kind of doing as you go.
So you compensated for the schedule slip of somebody else by working with your CM billing process.
Yeah.
Cool, thanks.
And one more thing is what he mentioned, when we do the statement of work for each of the projects, we sit down with the product managers and we see what the question you're coming up with is, which is budget is limited, and then we have all of these product lines that need an FCS on a certain quarter. And we sit down as project managers and say, hey, this won't work. You guys fight it out as to which one's the higher priority, because if you're not going to fund all of these, because we're going to go to the executives and say you can't launch all these products, and then so they'll make a decision. Then based on what marketing wants for this particular quarter, we go back to the contract manufacturers and the suppliers, and we work a statement of work that helps us get that. And that's what he's pointing to, those little caveats where, hey, can you bill us the next quarter?
Cool.
The last point I want to make here is that it wouldn't be uncommon that we're going to introduce a hardware platform and we don't have all of the functionality ready. CE is not going to accept that as a mode of business. If they open a box, they're replacing the box because it's likely that they're going to break the box. I've run into that company in the last 10 years. So we end up eating the box. So what happens is we have to make sure that any upgrade is introduced subsequently, firmware or software. So if you put it in your field or something like that, some new version of Wi-Fi, it's got to be in on the day that you ship, meaning regulatory, even if it isn't shipped as functional. So there are a lot of constraints on hardware. So anybody who thinks hardware is slow and waterfallish and all that stuff, there's a ton of constraints, and we work pretty hard to get around those. PMs do. Okay, so I'm not particularly an Agile guy, so I can't claim this as Agile, but there are a lot of things that we talk about